In this video, we're going to decompose time series into its constituent parts and then understand what makes up the key elements of time series. So, just in summary, the fundamental elements of a time series are first the observed data. Here I'm going to use an example of airline passenger flights. So how many airline passengers flew on flights in a period over 12 years. And the observed data is the actual data over time. Then there's a trend, a long-term average pattern that can be seen in the observed data. There's seasonality, which are some periodic repetitions that go up and down over time. And then there's some random noise or remainder, some unexplained random variations that don't fit either of these patterns. So now we're going to look at these elements in detail. First, the idea of the trend is the long-term average pattern. So in this observed data here, things go up and down, but there is an upward trend. That is, over this period of 12 years, there is an increase you can see in passenger flights. So there's lots of ups and downs in there, but the ups tend more upward than the downs tend downward. And that's what a trend is. Trends represents long-term factors, and managerially, they might be controllable factors, such as if a manager is doing a good job in making sure there's high quality flights that attract more passengers, their airline is more competitive, and so more people fly with that airline. Maybe they're expanding to different routes, so there's more opportunities, there's more business going on. So these are things that might be managerially controllable that affect a trend, but they might be external. So it might just be that the population is growing, and so there's more people to take flights. It might be that overall the markets for flights prices are dropping, and income is increasing. So overall, there's a long-term trend, and these are things that are not controllable, but at least a manager can foresee them and anticipate them and respond to them. So that's what trends generally represent. The next element is seasonality. And seasonality refers to periodic repetitions over time. So here, what you see is that for each period of time, so for each 1 year period, the sales, the flights start low, they bump up a bit, flatten, and they jump up, and then they dive down. Then they come up again, slightly jump up, and then dive down. And it's a repeated pattern over and over again. Now, on the observed data, it doesn't look exactly like the seasonality, but the seasonality more or less captures those bumps. It shows that year by year there are bumps. And in this case, it's that there's a holiday period where there's a lot of flights, and then it dives down right after the holidays, and it gradually goes up, and so on. And that's what is captured here. There's a 12-month seasonality, because this is monthly data, so that's where it can be captured. Depending on the nature of your time series, the periods might be over each hour over the course of a day, such as maybe the number of people that come to your store. They might go, it might be high in the morning, right before work starts, and then dive down. Then during lunchtime, when people take lunch breaks, it goes up, then it comes down. Then maybe in the evening, when people get out from work, that's the highest part of the day. Then it might also vary over each day over the course of a week or a month. So maybe weekends are higher in your case than weekdays, or vice versa, depending on what nature what's the nature of the opening hours of your business. They might be monthly or quarterly over the course of a year. So there's different patterns to this seasonality. Managerially, seasonality typically represents, or most often represents, external uncontrollable events that repeat over time. So, like in the examples given, you as a manager, you do not control when people take holidays. So maybe here holiday flights are more frequent. Managers don't control that. Maybe you don't control people's working hours. So when people are more likely to come to your store or not, that's not something that you can control. However, there is some limited managerial control in seasonal factors, and that's mainly in foreseeing and responding to these factors. So, for example, you might not control other your customers' working hours, but you can respond by matching your opening hours to the hours where people are more likely to be available to come to your store. And in an airline situation, you might not be able to control when people take holidays, but you can respond by opening certain routes specifically when there's holidays, and when traffic is low, you close those routes or you reduce the number of flights. So managers can respond to seasonality, even though they often cannot control the external factors that drive the seasonality. Then, after decomposing the observed data for a general long-term trend and for seasonal repetitions, there's some unexplained elements which you just can't explain, and that is the random noise. It's also called the remainder in time series analysis. So now, on one hand, this is what by definition you cannot explain. But on the other hand, there are things going on in there. And if you can identify new variables, then linear regression or other techniques could help to explain what is contributing to those noise levels. So here there is some random variation in flights, but if maybe you add things like what are the prices of flights, the industry average prices of flights, maybe driven things by fuel prices at that time, or maybe you can look at things like what are alternatives, such as are cruises offering special offers at that specific time, or maybe there's some geopolitical conflict going on where people are less likely to travel to certain typical holiday destinations. So if you can incorporate this additional information, then suddenly a lot of what is noise becomes explainable, and you can more accurately predict or forecast what the observed data will be. The point is that if you can understand what is causing the noise, then as a manager, even if you cannot control it, you can respond to it. And what you don't understand, you cannot respond to. But by trying to break down the noise and trying to understand more what's going on, then you can take more effective managerial action. So with these three main components, with the trend, the seasonality, and the random noise, when they're brought together, they compose what is the actual data over time. So this is a combination of all these three elements operating together at the same time. And it's very hard to predict the future values of observed data without time series analysis, because other predictive approaches that do not use time series analysis might try to track the trend only. They might maybe identify some aspects of what is random noise, but they miss the seasonality. Time series analysis, by breaking down these three key components, has very high predictive value that other approaches do not. Now, that said, even if you can break down these three components, how exactly do you add them and bring them together to into your predictions for future observed data? So that comes to the topic of additive or multiplicative decomposition. So decomposition is how time series analysis looks at observed data like this and breaks it down into the trend, seasonality, and randomness. And there are two distinct ways, at least from a mathematical perspective, that when you've broken these things down, how do you bring them back together to make future predictions? The first basic approach is called additive decomposition. And the idea there is that when things go up or down, it's approximately by the same amount. So if it goes up 10 units or goes down 10 units, then that generally continues. Here's an example where there's no trend, so everything is flat. The ups and downs are about the same. They're about plus or minus 5 throughout. Here there is a trend, so things are going up. And the ups are roughly the same amount up, and the downs are about the same amount down, even if it's following a trend. So that's additive decomposition with additive seasonality. With multiplicative decomposition, when the ups come, each subsequent up goes higher up. So if a up is bigger, then the next down is much smaller. I'm sorry, if the up is bigger, then the next down is correspondingly bigger. If up is smaller, then the next down is correspondingly smaller. So here, with a no trend, everything's flat on 0. You can see that when the ups are small, the downs are small. And over here, when the ups are big, the downs are also big. It doesn't always go in one direction. It could start becoming smaller as well, but the point is that when the ups are big, the downs are also big, and vice versa. And there might be a trend. In this case, there is a trend angling up, but you still see that when the ups are small, the downs are relatively small. When the ups are big, the downs are relatively big. And that is multiplicative decomposition with multiplicative seasonality. Now, to tell the distinction in a time series data set is not always so clear, though in this case, there's a trend, but you can pretty much surmise that when the seasonality is constant, but you can see that when the ups are very small, the downs are small. And over here, when the ups are bigger, the downs are bigger as well. So you can surmise that this is a case of multiplicative seasonality. So those are the main components of time series analysis, which need to be brought together in order to make effective forecasts.